Hi guys, welcome back to 100 Days Machine Learning Crash Course. Today we want to talk about the visualization of CNN layers and how could we interpret the CNN layers. Okay, so we want to know that what are the intermediate features looking for. In other words, let's say we train a convolutional neural networks. Now we have some layers. So each of the filters learn different things to extract from image, and we want to know each filter, in fact, what are the things that a filter are looking for in an image. Okay, so there are different approaches to visualize intermediate layers. The first thing that we could do is for first layer, we obviously could visualize the filters. For example, for the AlexNet, if we train the AlexNet on ImageNet, then we will see for the first layer we will end up with these kind of filters. So for example, this filter probably extract the edges in this direction, okay, of the image. And as you could see, we have some different filters with different colors, means that some filters extract edges in certain color channel. And also we have some blob detection filters, okay, so we could interpret these filters for the first layer. Okay, so when we see the first layer filters, we could talk about which filter and how they work to extract different features from the image. Okay, and these are the first layer filters for different networks. For example, this is for ResNet, this is for ResNet with different layers, and this is for DenseNet. Okay. For let's see, for also the last layer, the thing that we could do is actually if we want to visualize the last layer, which is kind of feature vector of an image, then one simple way is to actually use dimension reduction methods like TSNE or PCA to reduce the dimension or use nearest neighbor. For example, let's say we want to visualize this feature vector. So we could pass an image, let's say this flower, to the network, and then we get some feature vector. Okay. After that, we could pass other images and then find nearest neighbors to that test image. Okay. For example, for this flower, the nearest neighbors are these images. Okay, so in this case we are visualizing this feature map, this feature vector. Okay, so the other method is to use PCA or TSNE to reduce the dimension of this dense feature vector to just 2 dimensions to be able to visualize the dense feature map. For example, in this case, you could see, in fact, these are the images for the feature vectors. The feature vectors, let's say, they have, this is the dimension of the feature vector. Then we apply TSNE to convert it to a 2D vector. After that, we could actually point the images in the space. Now, to be able to show them more visually better and more precisely, we could instead of using the point, we could use the image itself. So these are actually the points, but instead of points we use the resized version of the images, okay, to show those points. And if you see that the images that are close together, they are somehow similar to each other because they are in the feature vector space, they are close together. Okay, for example, as you could see, this image is some kind of similar to this image, and also it has some blobs that is similar to this, and so on. Okay, you could see the same thing in this region and all of these feature vector dimension reduction version. The next thing that we could do is that actually pass the image so we pass the image to the CNN and visualize the activation maps. So for example, if we have at the fifth layer we have 128 13 by 13 filters, then we could have 128 filters. Then we could actually visualize those filters as grayscale images. Okay, so as you could see in here. Okay, the next approach to visualize the filter for intermediate layers, so because now we want to talk about intermediate layers, and the TSNE or the reduction method was for the last layer. Okay, now we want to talk about intermediate layers. For intermediate layers, you could do this kind of visualization. Also, another method is to use maximally activating patches, and it basically says that if you want to visualize a filter, you could pass different patches to the network and extract the patches in which the activation of these neurons are maximized. Okay, so we pass different patches to the CNN and then extract or keep the patches that maximally activated this neuron, okay, or this filter. So we could visualize those patches as the function of that filter. Okay, the next approach is actually the visualization with a deconvolutional network. So let's say we have some filters and feature maps that now they are smaller than the input image. So we could do the inverse of that with deconvolutional neural network or with Decony Net to create again the images. Okay, so if we visualize them, you could see that we could visualize different filters and different layers functions in the CNN. Okay, with this method. For example, for the dogs, it seems that it extracts some kind of face of the dog. Okay. Okay, and this is the way that we use the deconvolutional neural network to in fact do the unpool and use the convolutional neural network to create those patches, okay, and those images. The next thing that we could do is that the occlusion experiment, in fact, we could occlude some patch in the image and then see the heat map of probability for each mask location. So this is another method to some kind of having visualization of convolutional network. Also, another method, it's called Saliency Maps. We could compute the gradient of class score. So let's say we obtained or we achieved some scores for different classes. Now we could calculate the gradient of this class score with respect to these image pixels, okay, and then take the absolute value to actually discard the sign of the gradient and just show them in the grayscale image, okay. So you could see the saliency maps for different images in here, okay. Or in other words, in fact they are telling us how CNN are how CNN is concentrating on which part of the image. For example, when we have this image, the CNN is probably are focusing on this part of the image, okay, which is the object, and in here the focus is on this part, okay. So this is a visualization method for CNN. The next method for visualizing the intermediate features is visualizing them with it is so-called guided backprop. So we pick a single neuron in here, and then we compute the gradient of this neuron with respect to the image pixels. So we have different pixels, we calculate the gradient of this neuron with respect to these image pixels, okay. So let's see the result in this case. So if we calculate those gradients, we could see that we will end up with some images, in fact, that are some kind of visualization of the intermediate features that are important for the neural network or for the CNN. And the next method to visualize CNN features is to use gradient ascent. In other words, to see which patch could maximally activate a neuron, we could in fact we could create that image with respect to this neuron. So we want to use the gradient ascent to maximize the activation function, which is f of I. So we want to create that I that maximizes this one, and also we could include another term which is natural image regularizer to make the solution of this optimization, because the solution of this is an image and we want this image to have some kind of natural shape. So we add a regularization term besides the neuron value to solve this optimization problem and the optimization problem, the regularization could be something like this to use the gradient ascent. Okay, so if we do that for different classes, for example for the last layer, you could see that, for example, for dumbbell we have, as you could see, a kind of template of dumbbells in here, and also for huskies we have some templates of huskies in here. If I'm not sure whether you could see those or not in different parts of the image, and we have the same thing for other objects. So these are the way to see how in fact a CNN could behave for the images, or for which of the features are important for the CNN. Okay, and there are actually different methods to do the visualization. The next thing that maybe we want to very shortly talk about it is finding adversarial examples for the network or fooling images. So this means that let's say we start from an arbitrary image and pick an arbitrary class, then we modify the image to maximize the class. So for example, let's say this is an elephant, and then let's say we want to pick the koala. So we try to change this elephant, change the pixels of this elephant to fool the network and make the prediction koala. And so it is really interesting that with just changing the few pixels, so the difference is something like this. Maybe you could not see that. So for this reason we have 10x magnifier to magnify the differences. So you could see that with just changing the few pixels, now the network predicts this image as the koala. And this is so interesting, and shows that we actually have lots of other things to do to make sure that our CNNs are like human and have the performance like the perception of human, because we know that it is definitely an elephant, but the CNN is making the wrong prediction. Okay, and the same thing for other objects. So yeah, in this session we just learned about how to visualize the intermediate features, the first layer filters and the last layer filters, and feature vectors, and know about the behavior of convolutional neural networks. Hope that it helps you to understand the behavior of convolutional neural networks. See you in the next session. Bye.